In this question, you have a table here giving information about some times in minutes that 84 customers spend in a coffee. And you need to work out an estimate for the number of customers who spend 20 minutes or less in the coffee. So you see that 20 is not in the bounds here of these intervals. So we'll have to do some work on the histogram to actually answer this question. So because the class intervals are not the same, you see it's 5 for the first one, 10 for the second one, it's 15 for the third one, 10 for the fourth one, and 20 for the last one. We need to draw an histogram, and what we need to plot is not the frequency, but it's what we call the frequency density that we can get by dividing the frequency right here by the class width. So this is what you get after you've drawn your histogram from the frequency density here. And one key thing to understand is that now the frequency is represented by the area. So if you have a look at this, for example, the first bar, the width is 5, the height is 1.2. 1.2 times 5 is 6, which is the corresponding frequency. So we can write down the frequency that corresponds to these bars. Here we have 6, here we have a 21, here we have a 33. And we are now ready to answer the question. We need to estimate the number of customers who spend 20 minutes or less in the coffee. So 20 minutes or less would correspond to the left side of this red line here. So we already have a 6, we have a 21. We need to work out the frequency represented by this part of the bar. We know that the height here is 2.2, that the width there is 5, and so 2.2 times 5 will make 11. So the total frequency for what's on the left of the red line is 6 plus 21 plus 11, which is 38, and this is the estimated number of customers who spend 20 minutes or less in the coffee. You can notice that this is only an estimate because we've assumed that the customers here were evenly spread out. You know that basically between 15 and 30 minutes, they were not all spending 20 minutes or 22 minutes or 35 minutes, but that the results here are evenly spread out. So that's why this is an estimate, because we cannot be sure of this. Let's have a look at another example now. In this question, we have an incomplete histogram given here and an incomplete frequency table given there, and we need to use the two to complete all of them. So you see that we have the frequency given for the second and the fifth interval, which are not represented on the histogram. We have the two bars here that do not correspond to any frequency. So the only data we have in common is here the first bar and here the frequency for the first class. So if we work out the frequency density for the first one, we need to divide the frequency by the width. We get 20 divided by 20, so the frequency here, the density frequency, is 1. So this means that here we can say that we have 1 on this scale. Extending the scale on the vertical axis, we can see that the height here on this bar is 4.5, and that the one on the next one is a 3. So the missing frequency here was divided by the class interval, which is 10, to give you this 4.5. So this means that this meaning frequency was actually a 45. And the missing frequency here was divided by 20 to give you this 3 there. So this means that this frequency was equal to 60. We can also complete the histogram now. If we divide the frequency by the width here, which is 10, we get that the frequency density for the second class is 3. And if we divide the 48 here by 40, which is the class width, we get 1.2. And here is your completed histogram. We are now ready for the last question that is a bit tricky. Well, we need to work out an estimate for the median time. So let's work out the total frequency for this set of data. We get 203, and so if we divide this by 2 to get half of the frequency, we get 101.5. So we want to find the limit in this histogram that split the area in two, that split the frequencies in two. So if you add up these three numbers here, you find that you have 95, so you still haven't reached half of the frequency. That will happen in the fourth interval. So we need to find where to put a line here so that the frequency is the same on both sides. Well, we know we already have 20, 30, and 45. This adds up to 95. So we have here a remaining 6.5 in area that must come from this part of the bar. This 6.5 is actually the area here of this part of the bar. We already know that the height is 3. And we need to find out about the width here. And you know that's 3 times the width should be equal to this 6.5. So this means that you can work out that W is 2.2, correct, to 1 decimal place. So we can now find the number corresponding here to this on the axis. This is 40 there plus 2.2, so we get 42.2, correct, to 1 decimal place. And this is our estimate for the median. You might wonder why this is only an estimate and not an accurate answer. It's because in the process here, we just assume that all the results are evenly spread out in between 40 and 60. And more simply stated, it means that, for example, if you split this into 2 equal rectangles, you have as many people here as you have there, and that not everybody is crammed between 50 and 60 instead of being evenly spread out. So this was our assumption to work out here this 42.2.